Lesson 11 is ratios and fractions and their unit rates. So we're going to be doing a lot of the same stuff. We're going to be taking ratios and simplifying them to unit rates. But these ratios are going to have fractions within fractions. They're called compound fractions, or they're called complex fractions. So let's take a look at one. The example is called Who is Faster? During their last workout, Izzy ran 2 1/4 miles in 15 minutes. And her friend Julia ran 3 3/4 miles in 25 minutes. Each girl thought she was the faster runner. Based on their last run, which girl is correct? So we have two girls debating on which one's faster. We're going to figure out who is. So first thing you want to notice is they went different distances. Two 1/4 miles and 3 3/4 miles, but they also ran for different amounts of time. 15 minutes for Izzy, 25 minutes for Julia. So there are several strategies to use for this. We're going to do one, and then I can show you guys another one in class called a double number line, which you might like. But on the video, we're just going to work through it and find a unit rate. So you have your paper in front of you. I'm going to click over to another slide, and we're going to write down the information. You can show the work right where there is a space on your paper. So first of all is Izzy. She runs 2 1/4 miles in 15 minutes. So we're going to write that as a ratio. Izzy runs 2 1/4 miles in 15 minutes. And we're going to do the same thing for Julia. She runs 3 3/4 miles in 25 minutes. All right, so the time for Izzy and Julia is represented with minutes. We're going to put this into a table that will convert those minutes into hours. So follow along with me here. We know that Izzy is running for 15 minutes. When you're talking about an hour, there are 60 minutes in an hour. So if we look at that as a fraction, she's running for 15/60ths of an hour. 15 out of 60 minutes. And that fraction simplifies. The numerator and the denominator are both divisible by 15. And so Izzy is actually running for 1/4 of an hour. So instead of 15 minutes, I'm going to put 1/4 of an hour. Same thing for Julia. She's running for 25 minutes. That is 25/60ths of an hour. That fraction will simplify by 5. 25 is divisible by 5, as is 60. And so our simplified fraction is going to be 5/12ths of an hour. So to make sure you're understanding, 15 minutes is the same thing as 1/4 of an hour. And 25 minutes is the same thing as 5/12ths of an hour. So we're converting our fractions from minutes as the time to portions of an hour. And you'll see why in a second. So Julia ran 3 3/4 miles in 5/12ths of an hour. Now we'll be able to make our conversions. We're going to make unit rates. So if we look just at Izzy, we have a denominator of 1/4. We need that denominator to be 1. So the easiest way to do that is just going to be by multiplying. 1/4 times 4. 1/4 times 4 is 4/4 or 1. So that would give us 1 hour. So then all we have to do is multiply 2 1/4 by the same thing, by 4. We'll show our work down here. We're going to rewrite 2 1/4 as an improper fraction. That would be 9/4. We worked on that a little bit today in the warm-up and yesterday in the warm-up. Times 4, 4/1. That's going to give us 36/4, or 36 divided by 4, which is 9. So Izzy is running at a rate of 9 miles per hour. A lot of fraction work there, but things that if we practice them, we're going to be very fluent with. Julia. Now, we can't do what we just did as easy with Julia because we don't know what to multiply 5/12 by to get 1. But you can keep in mind the rule that anything divided by itself is 1. So instead of multiplying, let's divide here. Let's divide by 5/12 because if you divide anything by itself, you get 1. So 5/12 divided by 5/12 is going to be 1 hour. And then we have to divide 3 3/4 by 5/12. So again, we're going to write 3 3/4 as an improper fraction. It will become 15/4. We're going to divide that by 5/12. Dividing fractions, you keep, switch, flip. And now we're going to multiply across. You can do something called cross simplifying, but we're not going to do that. I'm going to use my calculator, and you guys can as well. 15 times 12. 15 times 12. It's going to give us 180. So 15 times 12 was 180. 5 times 4 is 20. 180 divided by 20, you can just cancel out the zeros, and it's 18 divided by 2. 18 divided by 2 is 9. So when we did all that work, we're also getting 9 miles an hour for Julia. Meaning Julia and Izzy ran at the same rate. I didn't finish this table. I probably should have. In 15 minutes, Izzy ran 2 1/4 miles, and Julia ran 3 3/4 miles in 25 minutes. Didn't really need those in there, but they should be. Moving on to question number 2, and like I said, there's another way, several other ways to solve this problem. So if you're not really a fraction person, we're going to be able to look through this with something called a double number line. You still have to use fractions, but it won't be as much work. Let's look at example number 2. A turtle walks 7/8 of a mile in 50 minutes. What is the unit rate when the turtle's speed is expressed in miles per hour? So we're looking for a unit rate in miles per hour. Right now his speed is in miles per minute, so it's going to take some adjustments. Part A, to find the turtle's unit rate, Meredith wrote the following complex fraction. Explain how the fraction 5/6 was obtained. So if we're looking at the fraction she wrote, 7/8 is the number of miles. 7/8 of a mile. So she could label if she wanted to do this correctly. And they're asking us, where did she get the 5/6? Where'd that come from? We'll have to see because it says 50 minutes. So the question right now is this. Is 5/6 of an hour the same thing as 50 minutes? So we'll click over to the other slide to figure that out. Is 5/6 of an hour the same thing as 50 minutes? So if we set up a table similar to what we did on the first problem, we know that the turtle went for 5/6 of an hour. We want to figure out how many minutes that is. So what we did before was we took that 5/6, or the fraction that we had, and we converted it to have a denominator of 60 because there are 60 minutes in an hour. To get from 6 to 60, you multiply by 10. So we would have to do the same thing up here in the numerator and multiply by 10. 5 times 10 is 50. So indeed, 5/6 of an hour is 50 minutes, or 50 out of 60 units within the hour. So if we go back here, that's where the 5/6 came from, because 50 minutes is 5/6 of an hour. They're equivalent, so Meredith just chose to use a fraction instead of 50 minutes. And since they're the same value, she's allowed to do that. Determine the unit rate when the turtle's speed is expressed in miles per hour. We're going to have just enough time to do that. I'm going to set it up on another slide, and you guys will copy down, and then we'll try some of these exercises. So the turtle goes 7/8 of a mile in 5/6 of an hour. We need to know how far he goes in 1 full hour. So again, 5/6 doesn't multiply very nicely to become 1, but we know anything divided by itself will equal 1. So we're going to divide by 5/6. And we're going to end up doing the same thing in the numerator, 7/8 divided by 5/6. Show our work off to the side, and this will give us our answer. 7/8 divided by 5/6. To divide fractions, we keep, switch, flip, and then we multiply. 7 times 6 is 42. 8 times 5 is 40, so we have 40 over 42. It's an improper fraction. Remember, 40 would go into 42 one time. There would be a remainder of 2 40ths. 2 40ths will simplify down by 2. And our simplified answer will be 1 and 1/20th. So this turtle goes 1 and 1/20th of a mile each hour. Pretty slow.